Free body diagram is a drawing of a part of a complete system isolated in order to determine the forces acting on that rigid body. In simple words, we have to say that free body diagram is the representation of forces acting on bodies. Suppose there is a system consisting of more than one bodies, and these bodies are interacting with each other. So there is reaction force, action force. Okay, so the representation of that forces on that body is called free body diagram. So we will learn this concept by taking an example. Suppose first example, there is a horizontal surface, okay, and a block whose mass is m is suppose this block is a whose mass is m is resting on a horizontal surface. Okay, is resting on a horizontal surface. Okay, so there is a weight due to mass m, okay, which is acting on a downward direction, and the weight is defined as weight is equal to m into g, and the direction of this weight is in downward direction. Why? Because here g is the acceleration due to gravity whose direction is in downward direction. So the direction of weight is in downward direction. Then how we draw the free body diagram of this system? So to draw a free body diagram, firstly we have to separate all these bodies. हमको क्या करना पड़ेगा? सबसे पहले इन दो बॉडी को सेपरेट करना पड़ेगा. Then we draw a forces in that bodies. Okay, so suppose there is a block here A, okay, and there is a surface, suppose the surface is C, okay, then the weight of A which is acts on its center of mass and lie on downward direction. ठीक है, ये वेट हो गया डब्ल्यू ए जो कहाँ एक्ट करेगा? बॉडी के सेंटर ऑफ मास पे एक्ट करेगा और उसकी डायरेक्शन क्या होगी? डाउनवर्ड डायरेक्शन. ओके, so this weight apply a load on horizontal surface because it is lie on a horizontal surface. Okay, suppose there is a mass. Okay, suppose this is pen which is lie on a horizontal surface. So due to this weight, there is a action force acting on horizontal surface. So it apply action force. Suppose the action is N to the surface C. So, according to Newton's third law, every action there is equal and opposite reaction. So, the surface C apply a reactive force N, है ना, which is whose magnitude is same as the action force but in opposite direction. This is reaction. So, if we draw a free body diagram of A, we get WA which is in downward direction and N which is in upward direction. Okay, if we want to calculate the value of N, we have to will take equilibrium condition. What is equilibrium condition? A body is said to be in equilibrium only when the net force acting on a body is zero and net movement on a body is zero. Okay, means condition of equilibrium. यदि हमको क्या करना है, इसमें n की वैल्यू निकालनी है, तो n की वैल्यू निकाल के कैसे? इक्विलिब्रियम कंडीशन अप्लाई करके. तो इक्विलिब्रियम कंडीशन होती क्या है कि क्या हो कि उसमें नेट फोर्स acting on a body will be zero and the net movement acting on a body is zero. Okay, so here the net force is zero means net horizontal force is zero and net vertical force is zero. Then the body is in static equilibrium condition. So here n is equal to WA. This is the magnitude of WA, and WA which is equal to m into G. Okay, this is the free body diagram and its calculation. Okay, let's take second example. Suppose there are two blocks lie one on another. This is block A and this is block B. This is block A and this is block A and resting on a horizontal surface C. Here weight of A is greater than weight of B. Now we want to draw a free body diagram of this system. Okay, हमें इस बॉडी का इस सिस्टम का फ्री बॉडी डायग्राम बनाना है. सो फर्स्ट ऑफ ऑल हम क्या करेंगे? इस बॉडी को सेपरेट करेंगे. ओके, वी विल आइसोलेट दीज बॉडीज एंड ड्रा द फोर्सेस. सो suppose this is block B, okay, this is block A and this is surface C. Okay, so सबसे पहले हम किसकी बात करेंगे? B की. Okay, firstly we will draw a free body diagram of block B. So there is a weight which acts on its center of mass and acting in downward direction which is B, WB. Okay, due to this load, there is a action force acting on B, acting on A, क्योंकि जो B ब्लॉक है वो किस सरफेस के ऊपर नहीं रखा गया है, वो किसके ऊपर है, ब्लॉक A के ऊपर। तो ब्लॉक A के ऊपर क्या करेगा B, अप्लाई अ एक्शन, एक्शन, suppose this action is N B, okay, so there will be a reactive force which will be applied by A on B, whose magnitude is same but its direction is opposite. This is reaction force. So if we draw a free body diagram of block B, we get this is B, okay, weight is in downward direction and normal reaction is in upward direction. Okay, this is the free body diagram of block B. Now come to A. Here weight of A is in downward direction, okay, and the block A is resting on surface A. So block A is applying action on C. Action on C, suppose this is NA, then the surface apply a reactive force whose magnitude is NA. This is reactive force, reaction, but in opposite direction. So we get the free body diagram of A. Here weight is in downward direction. Here NB is acting on downward direction and NA is acting on upward direction. So and then the surface C, there is only one action, that is NA. Okay, so if we want to calculate these values like NA and B, so we will apply equilibrium condition, means net force is 0 and net moment is 0. By applying in equilibrium condition, we get NB is equal to WB, and here NA is equal to WA plus NB. Okay, here putting the value by of NB here, we get NA is equal to WA plus WB. Okay, this is the फ्री बॉडी डायग्राम एंड इट्स कैलकुलेशन। तो हमें इस तरह फ्री बॉडी डायग्राम बनाते हैं, और फ्री बॉडी डायग्राम बनाने के बाद हमें कैलकुलेशन करनी है ना, नॉर्मल रिएक्शन की वैल्यू निकालनी है। तो हमने क्या क्या अप्लाई किया, इक्विलिब्रियम कंडीशन। इक्विलिब्रियम कंडीशन क्या थी, ये मैंने बताया था, क्या होती है कि नेट फोर्स बॉडी में क्या होना चाहिए, जीरो होना चाहिए, और नेट मूवमेंट क्या होना चाहिए, जीरो होना चाहिए। ठीक है, ये हो गया। अब हम क्या करते हैं, एक और एग्जाम्पल लेते हैं, है ना, जिसका फ्री बॉडी डायग्राम बनाते हैं अपन, फ्री बॉडी डायग्राम। तो अब देयर आर थ्री स्फीयर्स, ओके, और ये वर्टिकल सरफेस एंड दिस इज हॉरिजॉन्टल सरफेस। ओके, सो टू ड्रा अ फ्री बॉडी डायग्राम, फर्स्टली वी विल सेपरेट ऑल दीज बॉडीज। सबसे पहले हम इन सेपरेट बॉडी को सेपरेट करेंगे। सो सपोज दिस इज स्फीयर बी, दिस इज स्फीयर ए, एंड दिस इज स्फीयर सी। ओके, नाउ फ्रॉम हम किसे बनाना शुरू करते हैं, बी से। ओके, so the block is the sphere B is resting on like that, so there is a contact between vertical surface and B, and there is a also contact between horizontal surface and B. So these two surface apply a reactive force because the sphere B want क्या करेगा, पुश करेगा वॉल को, the vertical wall को भी and horizontal wall को, so there comes to be comes a reaction force. Okay, the reaction force from vertical wall, okay, vertical wall to sphere B is like that, RB. Okay, similarly from vertical surface there will be a reaction. Suppose this is R by BX, okay, RBX, and this is RBY. Okay, and this line of action always passes through the center of sphere to maintain the equilibrium. Okay, if line of action does not pass through the center, then there will be no equilibrium. Okay, there is generation of movement, so direction always the line of action always intersect. So, okay, so from vertical wall there will be a reaction RBX, and from the horizontal wall there will be a reaction RBY. Now there is also a contact between A and B. So B want to push A, which is action force, then A also apply a reaction force to B. So there will be a reaction force between contact point between A and B. This is reaction of on B by A. His line of action is again passes through center. Okay. Then there is a weight of B which acts in downward direction. This is weight of B which is acting in downward direction. This is the free body diagram of B. And see here, see all the line of action of forces passes through a center. So this is in equilibrium condition. Okay. If this line of action does not intersect at a single point, then there comes to be a movement, generation of movement. Okay. So if line of action of all these forces meeting at a point, single point, then this force system is called concurrent force system. Okay. Okay. Now we will draw a free body diagram of C. Similarly, there is a horizontal contact and there is a vertical contact. So there will be two reaction. This reaction is RCX and from there RBY. Okay. And there is a contact between A and C. Similarly, there will be a reaction from A to C. Okay. And there is a weight WC. If we draw line of action of all these forces, this line of action is passes through the center. Then again there is a concurrent force system. Okay, so it is in equilibrium. Now we want to draw a free body diagram of block A. So there will be no surface contact between vertical surface and A and horizontal surface between A. So there will be no reaction. But there is a contact between sphere B and sphere C. So there are two reactions. Okay. First is reaction R which is acting on A due to B. See, RBA and RAB both are equal in magnitude. RAB is equal to RBA, but in opposite direction. That's why we use negative sign. Okay, this is Newton's third law. Okay, similarly, the reaction from C to A, this is RCA. Okay, and there is a weight which is in downward direction, WA. If we draw line of action of this force, this is passes through a meeting at a center. Okay, this is also a concurrent force system. So this is the free body diagram of this system. Okay, there will be a four forces. Okay, in B, similarly in C. Okay, and there will be three forces in A. This is the free body diagram of this system. Let us take a third example, which is quite important. Here, a roller of 30 mm and weight is 100. Okay, weight is 100 Newton, 1000 Newton. Weight is 100 1000 is pulled over a curve. Okay, of height 15 mm. Height is 15 mm by a horizontal force. Okay, we want to rotate. We want to start a roller. So we are applying a horizontal force P. Okay, at the end of string wound around the circumference of the roller. What is the magnitude of P? What is the magnitude of load P required to start the roller over the curve? We want to calculate the magnitude of load P which is required to start the roller. Means just start करने के लिए रोलर को हमको कितनी फोर्स की आवश्यकता होगी, है ना? How much magnitude of force we need to start the roller. So we will find out by. So firstly here we will only draw free body diagram. Okay. In every question, if you want to calculate, so firstly you have to draw a free body diagram so that our calculation will easy. Okay, so how we draw free body diagram? So मैंने बताया था कि फ्री बॉडी डायग्राम बनाने के लिए सबसे पहले हम बॉडी को क्या करते हैं, सेपरेट करते हैं. वी हैव टू आइसोलेट बॉडीज, देन वी ड्रा द रिप्रेजेंटेशन ऑफ फोर्सेस. ओके, सपोज दिस इज द स्फीयर. ओके, so here suppose this is the center of mass and from there is a weight which is equal to 1000 Newton. Okay, weight is always in act in downward direction. Okay, now and there is a force, horizontal force P. Okay, which is applied to rotate start to roller over the curve. Okay, now जैसे ही ब्लॉक एज द ब्लॉक स्टार्ट ब्लॉक विल सेपरेट फ्रॉम दिस सरफेस, जैसे ही ब्लॉक क्या होगा रोटेट करने की कोशिश करेगा, सबसे पहले उसका जो कांटेक्ट पॉइंट है यहां से खत्म होगा, जैसे ही कांटेक्ट पॉइंट खत्म होगा यहाँ से कांटेक्ट पॉइंट स्टेब्लिश रहेगा. ओके, द roller is start to move. Okay, so firstly there is a separation between these two surface. जहां यहाँ से पॉइंट कांटेक्ट खत्म हो जाएगा तो there will be no reaction. Okay, there is a only single reaction from that surface. Suppose this surface is A and there is a point contact. Okay, so there is a point contact, so there will be a reaction and this is applying a reaction. But here see, पिछले केस में बनाया था मैंने, देयर इज अ कॉन्करेंट फोर्स सिस्टम. ओके, in concurrent force system the line of action of all the forces meeting at a single point. Okay, then this is called concurrent force system, where if body is in static equilibrium condition then the net force is in zero and net movement is zero. Okay, so here हम क्या करेंगे, हम जो ये लोड जो कैलकुलेट करेंगे, here we want to calculate the load. Okay, P. सो हम यहाँ पे कौन सी इक्विलिब्रियम कंडीशन अप्लाई करेंगे, स्टैटिक इक्विलिब्रियम कंडीशन. वी विल अप्लाई स्टैटिक इक्विलिब्रियम कंडीशन. ओके, स्टैटिक इक्विलिब्रियम कंडीशन टू सॉल्व द वैल्यू ऑफ पी. सो इन स्टैटिक इक्विलिब्रियम नेट फोर्स इज जीरो एंड नेट मोमेंट इज जीरो. ओके, सो for that the line of action of all the forces, a body set here, the line of action of all the forces is will passes through a single point. Okay, इस ये कंडीशन अप्लाई करने के लिए फोर्स सिस्टम कैसा होना चाहिए, हमारा कॉन्करेंट फोर्स सिस्टम होना चाहिए. मींस ऑल द फोर्सेस पासेस थ्रू अ सिंगल पॉइंट. सो देखो पी का लाइन ऑफ एक्शन, इफ वी ड्रॉ लाइन ऑफ एक्शन ऑफ पी इज लाइक दैट, लाइन ऑफ एक्शन ऑफ डब्ल्यू इज लाइक दैट. ओके, दे विल इंटरसेक्ट एट पॉइंट, सपोज दिस इज ओ. ओके, नाउ दैट एंड इट्स सेंटर इज, स्फीयर का सेंटर कहां पे है, सी पे. देन if we draw a free reaction force like that, then it passes here. In previous case the reaction force, the line of reaction force passes through the center. If we draw a reaction force and if its line of action passes through the center, then here there will be no concurrent force system, because the line of action of P is like that, the line of action of weight W is like that, but the line of action of this reaction is like that. So this is not non-concurrent force system. So there is a moment generation, है ना, movement develop हो जाएगा. तो इसका मतलब ये क्या है, ये this is wrong, this is wrong. So how we will draw free body diagram? So here this is center C, weight is acting on downward direction which is 1000 Newton. Okay, the load is applied on a circumference of a sphere, this is P. Okay, so and the line of action of P is like that and the line of action of weight W is like that. So this is the point O. If we draw a reaction like that, then the line of action of R is passes through the, so this is the right phenoid diagram. Here this is concurrent force system. Why concurrent force system? Because all the line of action of forces are meeting at a point O. Okay, if there are number of forces and their line of action are meeting at a single point, then this is called concurrent force system. Okay, so then now we will apply static equilibrium condition, means net force is equal to 0 and net movement is equal to 0, and find the value of P. Okay, this is the free body diagram. Okay.